A river which is 100 meters wide flows east at 1 meter per second. A swimmer who can move 2 meters per second is in still water aims straight north. How long will it take to reach the opposite bank? Let's figure this out. We need to draw a picture. So we have two banks, let's say, and we have a swimmer, okay, who is, let's say, starting on this bank, trying to get to this bank over here. And the swimmer has a horizontal velocity, right, of 2 meters per second. Horizontal velocity of 2 meters per second. However, the river is moving, oh, I see. So the river is moving east at 1 meters per second, but we're just going to say it's moving downwards. So let's say that river is moving this way, okay? And that's going to be, because here the direction isn't going to matter that much, okay? So the river is moving this way, which is going, and it's going to be at 1 meters per second. And so the swimmer essentially has a horizontal velocity of 2 meters per second, and then they are being pulled by the river downwards 1 meter per second. So their net vector of movement is this way, okay? That's their net vector of movement. So how long is it actually going to take to reach the opposite bank, okay? Well, in reality, all we need to do is just figure out how long it's going to take them to get horizontally to the other side, okay? Because even though they won't end up exactly here, they'll end up down here somewhere, it's still going to take them the same amount of time to get across in the horizontal direction. It just depends on their horizontal velocity. So how can we figure out, which seems to be constant, right? So how can we figure out the time it takes? Well, we know that the final position is equal to the initial position plus the velocity times time. Okay, so we just need to solve for time. We know that xf minus x naught, if we solve for it, is equal to v times t. This whole thing is the displacement, delta x, and that's equal to v times t. Well, the delta x is just the change in displacement, which is 100 meters, right? So we need to solve for the time, and so the time is simply delta x divided by the velocity in the x direction, the 2 meters per second, and that's simply going to be 100, right, divided by 2, which is going to be 50 seconds, right? And so C is our answer.